Hello guys, how are you all doing? I believe you are all doing good. Welcome to another session of Math. Today we are going to differentiate what I said in my previous video that we will be doing. The particular integral that we saw in our previous video, the answer that we had to it. Remember in that video I said that we are going to differentiate or we'll be differentiating that particular answer, and that is what I'm going to do in this video for you guys. So today in this video we are going to differentiate the whole of this part, that is square root of x squared plus 11x plus 30 minus natural log absolute value of square root of x plus 6 plus square root of x plus 5, which was the answer we had to the integral we solved in that previous video. I believe some of you have already tried and has been successful. Others have also, but might have or probably might have guessed that because of this absolute value what here. I know absolute value might be giving some of us problem, but you don't worry. By the end of this video, you get to know how to differentiate natural log together with what absolute value. Okay, so without wasting much time, let's get into the video. So let's write our solution first. Now we are going to form equation for this one. So you're going to let y be equal to the whole of this. Okay, so let's form our equation. All right. Now you're going to start with this one first. We're going to differentiate them separately. We will differentiate this one, and when we get our answer for this, then we move on to this one, and then we differentiate that one also. When we are done, then we put our answers together as we used to do. Okay, so let's quickly start with this one without wasting much time. We are going to put m be equal to square root of what x squared plus 11x plus what 30. Okay, so yeah, here we can differentiate it directly from here, but I'm not going to do that. I'm going to make it very simple for you. I'm not going to include any complex calculations here. I'm going to make everything very simple for you. So instead of differentiating the whole of this together with the square root, I'm gonna first going to let do another substitution, that is let u be equal to x squared plus 11x plus 30. Differentiate that one, know the answer to the derivative of this, and then we replace this one with u, then we differentiate that one, so then we multiply the two answers together. To do that, differentiate something of this nature requires what? Chain rule, but because I always use the formula, I always like forming the equation. I don't actually show that workings here. The moment you form equation with it, whatever you do reflect what indirectly reflect what the formula, that is the chain rule formula. Okay, so but we are not going to use the chain rule, so we are going to do another substitution. You're going to let u be equal to what is inside the square root, that is x squared plus 11x plus 30. Okay, all right, now let's differentiate. So du be equal to, now when you differentiate, you're gonna get du is equal to 2x plus what? 11 dx. 2x plus 11 dx. All right. Now you will not bother finding dx, okay, because when you differentiate the original one, we will get du, and then we will replace du with what? This one. Okay, so let's replace this one with u, and then let's differentiate in the original equation. So m is equal to square root of u. All right, so m is equal to square root of u. Now you already know how to differentiate this. So when you differentiate this, we're gonna get 1/2 times 1/2 times square root of what? U du. And you already know why, so I'll not waste time explaining it. Okay, so dm is equal to 1/2 times square root of u du. All right, now the main equation has been differentiated. That is dm is equal to 1/2 times square root of what? U. Good. We are done with the differentiation for the square root of x squared plus 11x plus what? 30. So, but we are having u here. You have to go back to what? The original word. Okay, so going back to the original word, we know that u is equal to this one, and then du is equal to this one. Okay, so let's quickly replace them and then see what we are going to get for the whole of square root of x squared plus 11x plus 30. Now when we replace them, replacing them is going to reflect what the chain rule formula, how the chain rule formula works. The main one will multiply what we did under it, that is u is equal to x squared plus 11x plus 30, and that one gave us this one. So we are going to replace this du with this one, and then also u with what? The whole of this. Okay, so now when you replace it here, the u is multiplying it, so when this one come down here, it's gonna what? Multiply. Okay, so when it multiply, you're gonna get dm over dx is equal to 2x plus 11 over 2 times square root of x squared plus 11x plus what? 30 plus what? 30. Good. Yeah, this showing this time that didn't come. Yeah, didn't show that part, and because you already know how to deal with that, the whole of replacing this one with this, and then this one with this, and then multiply will definitely give you this, and most of you are good at it, so there's no need for me to show that part again. That one is very easy. That is why I wrote the answer directly for you guys. Okay, so the answer to the square root of x squared plus 11x plus 30 is equal to, that is dm over dx. When you differentiate that one, this is what we are going to get. Okay, now this is our answer, but we are not going to rationalize in this case. I remember in the other video, the somebody asked that, okay, what if I don't want to rationalize the various answers that I'll be having after or before getting my finals? What if I don't want to rationalize them, but rather do the rationalization aspect in mind, or where I get my final answer? Well, we can do that. So in this video, we are not going to rationalize the individual answer that we'll be getting for each of them. Okay, but rather we will rationalize the final answer for that one that we have to do. Okay, so we will leave this one as it is, and then we move on to the next one. And the next one, when we are done, we will not rationalize. When we put our two answers together, compute it, the final answer that we get, then we rationalize it. Okay, so now let's move on to the other part. You're gonna let what? So the other part, you're gonna let p be equal to natural log absolute value of square root of x plus 6 plus square root of x plus 5. Good. Here too, we are going to do our substitution. I believe the absolute value here, there's two verticals. It might give you, it might scare you, or it might, impede you from trying to differentiate the whole thing, because that one you might think of what would be the answer to this. How are you going to even get rid of that absolute value symbol or absolute value sign over there? But don't worry, I'm just going to find out. Okay, so here we're going to do another substitution. You're gonna let t be equal to what is inside the absolute value, that is square root of x plus 6 plus square root of x plus what 5. Okay, all right, now t is equal to this one. This one we can differentiate it, and with this we are not going to do any other substitution again, because we know that the derivative of this one will give us what 1, and this one will be what 0. So ideally we will just treat the whole of this one as what one variable. Let's say u, or let's say m. When you treat it as, let's say, k, when you treat it as k, it will become something like square root of what k. Now square root of k is the same thing as the square root of what u. How we differentiated the square root of u, it will be the same thing as what how to differentiate what square root of k. Okay, so when you differentiate square root of k, you're gonna get 1 over 2 times square root of k. So the same thing is applied here. To differentiate this one, this and this one will give you 0, this one will give you 1. And with this one, just when you multiply, actually gonna give the same answer. So I'm just going to get 1 over 2 times square root of what x plus 6. Just put your focus on the power bracket, this one, and then rewrite the square root sign as 1 over 2. When you differentiate what is inside here, you're just going to get 1. So you just bracket it. Focus on the square root, the value of the square root sign, which is what 1 over 2. Now that 1 over 2, to differentiate that, you bring the half down, then you decrease the power by minus 1, or decrease the power by 1, and that will give you what minus half. Now applying that law of indices, that negative index of indices, you're gonna get 1 over 2 times square root of what x plus what 6. The same thing is applied to this one. Okay, so this one will just give us the t will be equal to 1 over square root 2 times square root of x plus 6 plus the same thing is applied here, 1 over 2 times square root of x plus what 5. Good. This one here is the other part we didn't rationalize. Alright, that was the main answer to that one, and we didn't rationalize. But here, if we don't rationalize this one, it will be some, though is the final answer, but not the final answer yet. It's not final answer to this one, that is p is equal to natural log of the whole of this. No, this one is under this one. So this part, let's rationalize this part. But the final answer to the derivative of what p will not be what rationalized. That's what I'm talking about. But after this one, we have to rationalize it. Okay, all right, you don't just get confused, you get it. Okay, so this one, let's rationalize. To do that, this times this, and then this times that, and then this times this one. And when you do that, you're going to get Okay, when you do that, this is what you are gonna get. You're gonna get this time. This will give us 2 times square root of x plus 5 plus this times this one will give us 2 square root of x plus 6 divided by, now this times this will give us 4 times square root of x plus 6 and then times x plus what? 5. Good. Well, you know that now you see why I said we should rationalize. Now we are having 2 here, we are having 2 here. You can factor out the 2 and then we do some cancellation and then we get a what? The complete answer for the derivative of what? This one. We have to rationalize this. Oh, you have to rationalize what this part just to help us, get the derivative of what? P. Okay. So now let's factor 2 out. Good. Now when you factor 2, as for this one, when you multiply this and that, definitely you open the bracket. So here is this times this one will give us what? X squared plus 11x plus 30. X times this one give us what? X squared, and then x times 5 will give us 5x. 6 times 6 will give us 6x. 5x plus 6x will give us what? 11x. And then 6 times 5 will give us what? The 30. Okay, so these two here will goes into 4 how many times? 2. So this one will just cancel out with this one, it will be left with 2 or 2. So actually dt over dx will be equal to square root of x plus 5 plus square root of x plus 6 over 2 times square root of x squared plus 11x plus what? 30. But don't bother finding the t over ds because at the end of the day we have to find what is going to replace what? The t in the original equation. Okay, so let's leave this one for now and let's put t into where the absolute value is and then differentiate that one also. Okay, so you're gonna get alright, so let's put t there. Good. I hope this is where some of us might get stuck when you maybe when you are trying your hands on it. P is equal to natural log absolute value of what? T. How are you going to differentiate that? Well, stack or any idea? Well, what we are going to do here is that actually there is a rule for differentiating what? Absolute values. Okay, but to differentiate this one, we are just going to get 1 over t. 1 over t. And how did we get the 1 over t? Now, to differentiate this one, this is what we are going to do. Good. We will let's say we have to I'm going to I'll just write the answer directly for you guys, but I'm just going to say how this one is what differentiated. But you don't worry, I'm working on another video. I'm working on another video which shows step by step on how to differentiate natural log together with what? Absolute value. Every step is what shown. Here I'm just going to omit some step. I will not be showing everything here, but I'm just going to talk about it yeah. Okay, so this one will just give you 1 over t. How did I got my 1 over t? This one is something that we are not familiar of or that we don't know much, but we know that we are more familiar with natural log of, let's say, k, natural log of, let's say, z, or let's say p. Yeah, something like that. When you are asked to differentiate, you know that you're just going to get 1 over what? P. Good. So here, to differentiate this one, now I'm going to make this one be something that we are familiar with. So let's say y, let's say something like n is equal to absolute value of what? T. And when you differentiate it, first you consider what is inside the absolute value, which is what? T. Then you differentiate. When you differentiate t, you're gonna get what? 1. Then the derivative rule for absolute value also says that after differentiating the t, then you take the whole of that derivative of the whole of absolute value of t, right? Then they will apply the differentiation rule on it, and when you apply that derivative rule, you're gonna get t over absolute value of what? T times the derivative of what? T, which is 1. So you're just going to get 1 times 1 over absolute value of what? T, which will give us what? T over absolute value of what? T. Okay, and here is what we have changed this one to what? N. So it has become natural log of what? N. When you differentiate natural log of n, you're gonna get what? 1 over n. And n is equal to what? That is the absolute value of what? T. Okay, so when we apply the chain rule, whatever that we had after making the substitution, just multiply them together. You're gonna get 1 over absolute value of t times t over absolute value of t. And with absolute value, what it means is positive and or either positive or what? Negative, because we don't know. That is why we are taking the absolute value. But now, when you multiply both of them, you're just going to get t over absolute value of t times absolute value of what? T. And remember, the moment you get squared, it becomes 2. We don't no longer need the absolute value, because no matter what you do, when you square it, it will be what? Positive. So that one will take the absolute value what? Away. Okay. And when you do that, you're just going to get what? T over 1 over t over t squared. And when you do cancellation, you're just going to get 1 over t. Okay. So that is how we differentiate this. I didn't bring these steps or what I'm saying here for you guys to see, because there is another video that I'm working on where I'll be showing you everything into what details, or I will show you everything. Okay, that is why he had decided not to what do it. Okay, so I just to give a hint of how or yeah, idea of how you can differentiate something of what this nature. Okay, so now dp will be equal to 1 over t dt. dp is equal to 1 over t dt. Now what is dt? We already know what dt. dt is just what here. That is dt is equal to the whole of this what dx. So let's replace t with what it was substituted for, and also the t with what this one. Okay, so the p is equal to, all right, this one I just brought it just to remember you what we substituted the t what for. So let's replace them into the original equation. So the p is equal to, good, this one is representing the t, and this one is what the derivative of this one is also representing what the derivative of absolute natural log absolute value of what t. After differentiation, we had 1 over t, and then after replacing t with this one, there is what we had, or this is what we have gotten. And then when we replace the t, this dt with the whole of this, We're just going to what? Get this. Alright. What we are going to do here is that let's see if we can do any cancellation. Here I have 1 over square root of x plus 6 plus square root of x plus 5 times square root of x plus 5 plus square root of x plus 6 divided by 2 times square root of x squared plus 11x plus 30. Good. Here we can see that this and then this are the same. Okay, so this one will cancel out with this one, and we are going to get dp over ds will be equal to 1 over 2 times square root of x squared plus 11x plus 30. Okay, so dp over dx equal to 1 over 2 times square root of x squared plus 11x plus 30. Now this is the answer to the natural log part. Okay, I said the main answers we are not going to rationalize what them. The other part you rationalize just to eliminate others. Okay, so I'm not going to rationalize this ones. Okay, so now that we have gotten our answers for both of them, let's put them together. But remember that when you are going to put your answers together, we have to indicate something that will show that the equation has been what differentiated. Okay, so you're not just going to write y is equal to, you're just going to write dy over what dy over ds, meaning we have differentiated it, and what is left with is maybe some algebra aspect or some computation that we are going to do. Okay, so we are going to add dm over dx and then dp over ds together. We didn't bring a and b, so this one is will give us an idea of what we are talking about, and this one also give us an idea of what we are talking about. This one is representing this, and this one also representing the answer we had to the other one, that is where m was equal to the square root of x squared plus 11x plus what 30. Okay, so now let's add them together. Remember the original equation, it was what minus, so this one will be minus. That is why the minus sign is what here. It should have been plus, but we decided to make it minus because the original equation we were subtracting. Bear in mind that we didn't carry the negative sign along, so when you go back to the original equation, whatever sign that was there has to be what maintained. Okay, so dy over dx is equal to dm over dx minus dp over dx. Okay, now let's continue. So dy over dx is equal to this one. This is what we had for this, and then this one is what we had for what this one. Good. Now as you can see, this and this are having the same denominators. This one is the same thing as what that. Okay, so it's a like fraction. It's a like fraction. All that we are going to, since it's a like fraction, what we are going to do here is that we're just going to write one of the denominators and then subtract what the exponent. Okay, so you're just going to get 2x plus 11 minus 1 divided by 2 times square root of x squared plus 11x plus what 30. Okay, all right, now when we take 1 from this, I think we are gonna get 10. So dy by dx equal to 2x plus 30 divided by this. Alright, what can we do here? Well, this one here, I think we can do something to it. We can eliminate this one by factorizing this. When we factorize this one here, that is 2x plus 5, 2x plus 10, sorry, we are gonna get 2 outside, x plus 5, and that 2 will cancel out with this one. So let's factorize this one. Now when you factorize this, you're gonna get what? 2 into bracket x plus 5. Okay, so dy over dx is equal to 2 into bracket x plus 5 divided by this. Now here, this and this will cancel out. This and then this one will cancel out, and it will be left with x plus what? 5. Alright, so dy over dx over dx equal to x plus 5 over square root of, yeah, here I chose to factorize this side because you remember in that previous video I said I will do my possible best to get what we actually integrated, how the question was presented to us. I will do my possible best to get that same thing for you guys. So that is the motive of what factorizing the quadratic expression was here. Okay, so you're gonna get x plus 5 divided by square root of x plus 6 times x plus what? 5. Good. What are we going to do here? Since this one is the answer to the derivative that we are solving, what are we going to do? I said always when you get your final answer and it's of this and it is of this form, don't leave it like that. Just rationalize it. Just what? Rationalize it and take away the set from the denominator's position. So here we are going to rationalize, and to rationalize, we already know how to rationalize, or yeah. So we're just going to multiply this one and then this, the whole of this one, by the whole of what? This one. That is x plus 5 over square root of x plus 6 times x plus 5 times square root of this one divided by this one. Okay, good. Now here don't do any cancellation because we are rationalizing. So this times this and then this times this as usual. This times this one will give us what? This one squared, and then this one squared will give us what? X plus 6. X plus 6 times x plus 5, and then this times this one will just give us this times this one. Don't open the bracket or don't multiply this by the whole of this and then also this by the whole of this. Okay, good. Now dy over dx equal to x plus 5 times square root of x plus 6 times x plus what? 5 divided by x plus 6 times x plus 5. Here we can do cancellation, so this one will cancel out with this one to be left with the whole of this over this one. Okay, and remember this one here can also be applying the multiplication law of said. This one here can be written as square root of x plus 6 times square root of x plus 5. Okay, Good. So as I said, this one can be written as what? Square root of this times square root of what? That. You know, actually this is the answer to the final answer to the what? The derivative question that we are solving. You know, that particular integral, when you rationalize it, that is what you are going to, this is what you are going to get at the end of the day. So that is why, remember I said it that in that video, when you rationalize it or when you differentiate it, maybe that is where you definitely you are going to what? Reach. No matter what you do after the rationalization, this is what you are going to get, unless maybe you didn't rationalize as I have what done mine. Maybe you didn't do that way, but you did it in another what way. Yeah. Okay, so when you rationalize, this is what you are going to get. So when you get this, you are not wrong, you are not wrong, you are correct. But you remember I said that I will do my possible best to get what we actually integrated, that is how the question was presented. I'll do my possible best to get how it was presented, the how it was looking. We're just going to um, um, continue from this one to get that. Okay, and I'm going to show you right after what this part, and that is even the reason why I um, factorize this one, so that I can place it and use it to show you how to get that one back. Okay, so from the multiplication law of said, this one can be written as square root of this times square root of what? This. Multiplication addition is commutative, so you don't worry. Alright, so here, this one here can also be written as square root of x plus 5 times square root of x plus 6 divided by x plus 6. Okay, good. Yeah, here what we are going to do to get how it was presented, we are going to rationalize this one again, but this time we are going to remove this one from here and bring it down here. Okay, so that when you multiply, this one will be on top and then this one will what? Come down. Okay, and this 6 will be what? Eliminated. Maybe we should have done that one earlier on, but I just wanted to show you the rationalization aspect and also show you what this one. So in any time that you solve any differentiation question that was of this form and you wish to get back how it was presented for you when you were integrating, maybe then you know what to do. Okay, so that is the reason why I didn't show this one out. I didn't bring this one directly for you guys. So I wanted to show you the rationalization aspect and also what? This part. Okay, so here they're going to multiply both top and down by what? Square root of x plus what? 6. Okay, good. Here this time this will give us what? This one squared, and when you square it you're gonna get x plus 6, and then this one time this one will give us what? X plus 6 times square root of what? X plus what? 6. Okay, and when we multiply x plus 6 by this one, we're gonna get x plus 6 times square root of x plus 5 divided by the product of what? This and then that. Okay, now remember that x plus 6 will definitely be cancelled out with this one, and we will be getting this one over this one. Okay. Good. So as I said, uh, when you square this, the answer that we're going to get will cancel out with this one. So that is what is reflecting here. Now here and here are the same. So this one will cancel out with what? This one, and to be left with this over that. Okay. So dy over dx is equal to square root of x plus 5 divided by square root of x plus 6. You see, this one here was actually the problem we saw in our previous video. You see how um I manipulate the rationalized part to get what? This one back. We could have done that one directly without showing the rationalization what aspect, but because I wanted to show you this one and the rationalization, so that maybe when you get to rationalization part and then you wish to proceed further to get how it was presented to you, then you know what to do. Okay, maybe next time I will omit the rationalization aspect and continue and then proceed to steps of what getting this one directly. Okay, all right, so let's end it. Therefore, the derivative of the derivative of this one is equal to, you see here I've written two answers for you. It's either equal to this one or this one. When you rationalize this one, this is what you are going to get. When you rationalize this one also, yeah, this is what you are going to get. So here is 11 square root of 11, square root of x squared plus 11x plus 30 over x plus 6, or square root of x plus 5 divided by square root of x plus what? 6. Okay, so guys, the answer to this derivative question is either square root of x squared plus 11x plus 30 divided by x plus 6, or this one, or this one. Any of them that you leave your answer in, either this way or that, you are correct. But because I wanted to I wanted to honor what I said, that I will do my possible best to get this one back. That is why I included this one too as part of the final answer. So if you wish to get that one, I mean, you now know how to get you now know how to get it back. You know how to manipulate this one towards get this one. When you rationalize it, you're gonna just going to get this one. And then also when you manipulate this one further, this is also what you are going to get back. Don't leave your answer in both. Just choose one, either this one or what this. But I prefer you leave your answer in the rationalized form. This one here, because of what I said, I wanted to prove that you will definitely get it back. Okay. Alright, that's it guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.